All right, welcome to the deep dive. Today, we're going deep on something pretty fundamental, I'd say. Logic. The stuff that underlies how we think, how we argue, really how we make sense of, well, everything.
Yeah, exactly. We're not talking, dry textbooks or those equations that make your eyes glaze over.
Yay.
We're talking about that framework, the very framework we use to sift through all the noise and figure out, well, what makes sense and what's just, well, nonsense.
And it's a puzzle, right? It's a puzzle that thinkers have been wrestling with for thousands of years.
Right.
Luckily, we've got some really fascinating sources here, materials that trace how logical thought has evolved over time.
Yes, a great collection really highlighting the historical journey.
And our mission, what we're going to try to do today, is to pull out the most important pieces of that story, see how those ideas from way back when still affect how we think today, how we can think more clearly, more effectively.
Absolutely. The exciting part is seeing how these foundational ideas still resonate and provide us with tools, practical tools for better thinking in our daily lives.
Okay, so let's jump in right to the beginning. And when we talk about the origins of logic, at least in the West, one name kind of looms large, right? Aristotle.
You can't really talk about Western logic without Aristotle. Back in the 4th century BCE, he really set the stage for so much of what came after.
Yeah, and we have his Organon.
Right, the Organon, this collection of his writings on logic. And this is where he introduces syllogistic logic.
Now, syllogistic logic, that sounds intimidating.
It's really not as complicated as it sounds. Think of it as a very structured way of building an argument. You have your starting points, the premises, and they lead to a conclusion. And it's all in that very classic format of subject is doing something.
Okay, I see.
Like that famous example. All humans are mortal. Socrates is human, therefore Socrates is mortal.
Right, right. I've definitely heard that one before. Sounds simple, but it was a pretty big deal back then, wasn't it?
Oh, absolutely. It was about pinpointing valid argument structures.
Yeah.
Really clarifying how to move from those premises to a conclusion that actually follows logically.
But it wasn't just about the syllogisms, right? There's also the laws of thought that he laid out.
Right. Even more fundamental, I'd say. And there are three of them. We've got the law of non-contradiction. That's the idea that something can't be both true and not true at the same time, and in the same way, of course. Then there's the law of excluded middle. It says any statement, any proposition is either true or false. No middle ground. And finally, there's the principle of identity, which is pretty straightforward. It says something is what it is.
I mean, those sound kind of obvious, like duh, of course.
They do, right.
Yeah.
But they're actually the bedrock of classical logic. They're all about aiming for consistent reasoning, avoiding contradictions. And believe me, you can get into some really mind-bending tangles when you start messing with those laws.
So Aristotle gave us this formal system for logic. But was that the only approach back then? We've also got the Stoics.
Yeah, the Stoic school. They were around at the same time, and they were also doing some really interesting work in logic, especially Croesus.
And what were they focused on?
Well, they were more into what we now call propositional logic, or sometimes sentential logic. So instead of looking at the internal structure of statements, like Aristotle's subject-predicate stuff, they were interested in how whole statements connect, using words like if, then, and, or.
So while Aristotle's breaking down Socrates as a man, the Stoics are saying, well, what about if it rains, then the ground is wet?
Exactly.
Yeah.
It's a different but complementary way of looking at arguments,
Yeah.
focusing on how those connectives, those logical glue words, actually work.
Fascinating. It's like two different paths to the same goal, maybe.
Yeah, I think that's a great way to put it. And it's worth remembering, it wasn't just happening in Greece. Our sources mention contributions from other parts of the world, too.
That's right. Logic wasn't a purely Greek invention.
Absolutely not. The Naya school in India, for instance. Around the same time as Aristotle, they had this really sophisticated understanding of inference and debate. They had their own set of rules, their own methods for figuring out what follows from what.
So logical thinking was really happening all over.
It seems so. And then, of course, later on, we have the Islamic Golden Age. Figures like Al-Farabi and Avicenna, they played a huge role, not just preserving the works of Aristotle, but actually building on them, refining them.
So we're just copying the Greeks then?
No, not at all. They were integrating logic into their own theological and philosophical systems, which really shows how these logical principles could be applied in so many different areas.
It's like logic became this universal language, a way to think clearly across cultures.
Yeah, exactly. And it's so important to see these cross-cultural interactions, how they enriched and deepened the reach of logic. It wasn't just one straight line of development, but this rich tapestry of ideas from different traditions.
Okay, so we've got these different threads coming together. Let's fast forward a bit to medieval Europe. We see this renewed interest in logic within the world of scholasticism.
Right, the scholastic period, roughly 12th to the 14th centuries. Big revival of Aristotelian logic happening in European universities. Thinkers like Thomas Aquinas and Duns Scotus, they were using these logical tools to examine theological doctrines.
So even though they were working within a religious context, it actually pushed logic itself forward.
Absolutely. They weren't just playing mind games. These were serious attempts to test the consistency and coherence of religious beliefs using logic. And in doing so, they became incredibly sharp, making these subtle distinctions between types of statements and arguments, pushing for that logical precision, even if the focus was on theology.
It's like logic got a workout in the medieval gym.
Chuckles. I like that. And remember those Islamic scholars we were talking about? They were still making contributions during this period, too.
Right. Avicenna, Averroes.
Exactly. Avicenna, for example, he expanded on Aristotle's work. He looked at different ways to classify propositions and even explored new ideas about necessity and possibility. And Averroes, he wrote these incredibly detailed commentaries on Aristotle that were rediscovered in Europe and had a huge influence on the scholastics. It really shows how these logical principles have a kind of a universal importance that transcends cultural boundaries.
Yeah, it's like logic is this common thread running through intellectual history no matter where you are in the world.
It's a great way to think about it.
Okay, so from these structured, almost debate-focused refinements in the medieval period, we move into the early modern era, and we encounter someone like Descartes. He's not always thought of as a logician per se, but it seems like his work had some pretty big implications for the field.
Yeah, that's a great point. Descartes, with his focus on methodical doubt, really shifted the focus of how people approach knowledge.
Right, doubting everything.
Exactly. Yeah. He wanted to question everything until he arrived at those ideas that were absolutely clear and distinct. It wasn't formal logic in the way Aristotle did it, but that commitment to clarity, to getting rid of ambiguity, it aligns perfectly with the spirit of logic.
It's like he's saying, let's rebuild knowledge from the ground up, but this time, let's use logic as our foundation.
Exactly. And his famous cogito ergo sum, I think, therefore I am, while not a formal syllogism, it's a perfect example of a claim that he considered self-evident after that whole process of radical doubt.
And then we've got Leibniz with his idea of a universal characteristic. Now that sounds ambitious.
It was. Leibniz dreamed of this perfect formal language, a language where all reasoning could be encoded, maybe even calculated mechanically.
So like a logical calculator.
In a way, yeah. He never actually completed it, this Characteristica Universalis, but it's such a powerful concept because it foreshadowed the development of symbolic logic. He saw logic as something that could unify all areas of knowledge, from math to philosophy to science. A grand vision for sure.
Okay, so we're seeing the stage being set for a more symbolic and mathematical approach to logic. And then, boom, we hit the 19th century, and along comes George Boole.
Right, and Boole's work was truly revolutionary. His creation of Boolean algebra was a game changer. He took logical propositions and translated them into a mathematical system.
How does that even work?
Well, it's based on this simple idea.
Huh?
True is represented by 1, false by 0. And then you can use algebraic operations to represent logical connections like and, or and not.
So it's like logic meets algebra.
Exactly. And it's elegant, powerful. It opened up a whole new way of thinking about and manipulating logical relationships.
And then we've got Augustus de Morgan, who builds on Boole's work and provides even more refinements, right, to Morgan's laws.
Exactly. De Morgan was a key figure in this move towards algebraic formalism.
And what's the significance of that move, that shift?
Well, the work of Boole and de Morgan, it really marked a break from the more traditional way of thinking about logic, which was often so tied to language.
Right, it's getting more abstract.
Yes. By expressing logic in purely symbolic terms, they forged this really strong link between logic and mathematics. It allowed for a whole new level of precision, of abstraction in how you analyze arguments.
And it paved the way for even more sophisticated systems, right?
Exactly. And it highlights this key insight. By moving to symbols, you can escape some of the ambiguity of everyday language. Logic becomes more precise, more rigorous.
Which brings us to modern symbolic logic, right?
Yeah.
Late 19th, early 20th century. And one name that we absolutely have to talk about is Gottlob Frege.
Frege's work was groundbreaking. He's the one who developed predicate logic.
Predicate logic.
And for the first time, we had the tools to deal with quantifiers, those for every and there exists statements. It was a huge leap beyond the limits of Aristotle's logic.
So it's like a logic got a serious upgrade.
Exactly. Frege's system was so much more nuanced, so much more powerful for representing those logical relationships. And it really set the stage for everything that came after, even though it took a while for his work to be fully appreciated.
Yeah.
The key here is that Frege gave us the ability to analyze arguments with way more precision, especially when you're dealing with generalizations and existence claims, which the older systems really struggled with.
Okay, so Frege lays down the groundwork, and then you have, you have Russell and Whitehead with their Principia Mathematica. That was a huge undertaking, right? Trying to derive all of mathematics from logic.
It was an incredible project, incredibly ambitious. They wanted to show that all of math could be built on this rock-solid logical foundation.
And did they succeed?
Well, they ran into some problems along the way. Paradoxes, most famously Russell's paradox about sets that contain themselves. But even though that ultimate goal of deriving all of math from logic faced some serious challenges, their work in developing formal systems was hugely influential. They showed just how powerful and rigorous a formal approach to logic could be.
So it's like they pushed logic to its limits, and in doing so, they revealed some of its hidden complexities.
Yeah, I think that's a great way to put it. And at the same time, we had amazing work coming out of the Polish school of logic.
Right, with figures like Łukasiewicz and Tarski.
Exactly. Łukasiewicz, he explored this really fascinating idea of many valued logics, which challenged that whole idea that every statement has to be either true or false. He said, what if there's a third option? Or even more.
Blowing my mind a little bit.
Chuckles. Yeah, yes. It gets pretty wild.
Yeah.
And then Tarski, he made these huge advances in how we understand truth itself, developing a formal semantic theory of truth, how it relates to language, really influential stuff.
So early 20th century, it's a whirlwind of activity in the world of logic. And then we get to Wittgenstein. Now, at least in his early work, he had a very particular view on the relationship between language and logic.
Right, Wittgenstein. Yeah. His Tractatus Logico-Philosophicus. It presented a very radical perspective in some ways. He argued that language is essentially a way of picturing reality, and that the logical structure of language is what allows us to form meaningful statements.
So he's saying logic is baked into language itself.
In a way, yeah. And this idea was incredibly influential, especially on the Vienna Circle, the logical positivists. They believed you could use logic to clarify scientific language to separate the meaningful from the meaningless.
But didn't Wittgenstein kind of change his mind later on?
He did, yes. In his later work, especially the philosophical investigations, he moved away from that picture theory of language. He started to focus more on the practical uses of language, how meaning is shaped by context. It's a fascinating evolution.
Okay, so logic is getting more complex, more nuanced. And then we have perhaps one of the most significant, definitely thought-provoking developments of the 20th century, Gödel's incompleteness theorems. Now, these are notoriously difficult to wrap your head around. For someone who's not a logician or mathematician, can you explain why they were such a big deal?
Yeah, Gödel's theorems are, they're definitely mind-bending. Published in 1931, they basically show that any sufficiently complex and consistent formal system, like the systems we use in math, will always contain some statements that are true, but can't be proven within the system itself.
Wait, so there are truths that we can't prove?
That's essentially what he showed. It was a huge blow to this idea that we could create a perfectly complete and consistent formal system. He revealed that there are inherent limits to what we can prove using formal logic. It didn't mean logic was useless or anything, but it did show that even in our most rigorous systems, there are boundaries.
It's like logic has its own blind spots, right?
Yeah, in a way. It's a real humbling insight. And it really changed how people understood math and logic.
So on the one hand, we've got these theoretical limits being exposed, but then at the same time, logic is becoming incredibly practical, right, with the rise of computability theory.
Absolutely. In the 1930s, you got Alonzo Church and Alan Turing. They were working independently, but they both developed formal models to define what it means for something to be computable.
Computable.
Right, like can you solve this problem using an algorithm, a step-by-step procedure? And Turing's model, the Turing machine, along with Church's lambda calculus, They became the foundation for computer science.
So suddenly logic isn't just this abstract thing anymore. It's powering the digital age.
Exactly. Computers, algorithms, artificial intelligence, all of that is built on these logical foundations. It's an incredible transition from pure theory to these incredibly powerful practical applications. The key insight is that logical systems became the language of computers.
It really shows how adaptable these fundamental logical principles are. And that brings us to contemporary logic. What's going on in the field today?
Oh, lots of exciting stuff. Classical logic, with its black and white view of truth, true or false, it doesn't always capture the nuances of how we reason in the real world.
Right, things aren't always so clear-cut.
Exactly. And that's where modal logic comes in. It introduces concepts like necessity and possibility. So it's not just, is this true or false, but must this be true or could this be true?
Okay, I see.
And we have all sorts of modal logics now. Epistemic logic for reasoning about knowledge, doxastic logic for belief, temporal logic for dealing with time. These systems let us model much more complex stuff, get at those subtle shades of meaning.
And you mentioned some other non-classical systems too, like intuitionistic logic and fuzzy logic. Why are these needed?
Well, intuitionistic logic, for example, it takes a different approach to truth. It rejects the law of excluded middle in some cases, demanding that you have actual proof of something rather than just assuming it's true because you can't prove it false.
Okay, so it's a more demanding standard of proof.
You could say that, yes. And then fuzzy logic and many valued logics, they're all about dealing with situations where truth isn't just a yes or no question.
Right, shades gray.
Exactly. Something can be partially true, mostly false, and so on. Incredibly useful when you're dealing with vague or uncertain information. Imagine a self-driving car trying to process something like the light is probably red. Fuzzy logic can help with that kind of situation where classical logic, which only deals with true or false, would struggle.
That's a great example.
Yeah, then we've got relevance logic and paraconsistent logic. These are tackling some really fundamental challenges to classical logic.
Oh, how so?
Well, relevance logic is all about making sure there's a genuine connection, a relevant connection between the premises of an argument and its conclusion. It tries to rule out those inferences that might be technically valid, but just feel intuitively wrong. Like there's no real connection there. And then paraconsistent logic, it's even more radical. It tries to deal with contradictions in a controlled way. Classical logic says that if you've got a contradiction in a system, then anything goes. Anything can be proven.
This whole thing breaks down.
Yeah. But paraconsistent logic says, no, hold on, maybe we can still work with this. It's proving useful in fields like knowledge engineering, where you're dealing with messy data that might have inconsistencies or gaps.
So it's like logic is learning to deal with the messiness of the real world.
Exactly. It's not just about these pristine formal systems anymore. It's about developing tools that can handle complexity, uncertainty, even contradiction.
This has been a fascinating journey. It's clear that logic, well, it's not a static thing. It's always evolving, adapting. So for someone listening who wants to become a better logician, in their own thinking, their own life, what are some key takeaways? What advice would you give them?
Well, first and foremost, I'd say you have to build a solid foundation. Get comfortable with the basics of propositional logic. Understand how those if-then statements work, common argument forms like modus ponens and modus tollens. Then move on to predicate logic. Learn how to deal with those all and some statements. It'll help you analyze those more complex arguments.
Makes sense. Start with the basics.
Right. And a little bit of foundational mathematics can help too, especially set theory. It'll give you a deeper appreciation for how logic and math are connected.
Okay.
And don't be afraid to grapple with those historical paradoxes. Russell's paradox, the liar paradox, things like that. They're like little puzzles, but they can reveal a lot about the subtleties of language and logic.
So it's not just about memorizing rules, but really understanding how those rules work, where they break down, where they get interesting.
Exactly. And engage with the contemporary discussions. Read about what philosophers are saying about language, metaphysics, areas where logic is being used and refined. Experiment. Dip your toes into some of these non-classical logics. See how different approaches handle different kinds of reasoning.
So many possibilities.
Right. But most importantly, I think, develop your metacognitive skills. Be aware of your own thinking. What assumptions are you making? Are you being consistent? Strive for that precision and clarity in your language, how you define things. And practice, practice, practice. Apply logic to real-world situations, even simple ones. And talk to people, debate with people. It's the best way to sharpen those logical skills.
It's like logic is a muscle you have to exercise.
Exactly. It's not just about having knowledge, but about using it actively, critically.
Well, this has been a fantastic deep dive. We've seen how logic has evolved from these ancient philosophical questions to, well, the foundation of our digital world. It's a powerful tool, no doubt about it.
It is. And it's a journey that's still unfolding. The evolution of logic, it really reflects our deep desire to understand the world, to find clarity, to make sense of things.
Which brings me to a final thought for you, our listener. Think about this long history of logic. All the twists and turns, the breakthroughs, the dead ends, it's all part of this human quest to understand truth, to build coherent systems of thought.
It's an ongoing process, for sure.
And maybe even more provocatively, what might the future of logic hold? What new discoveries might we make about the nature of truth, about how we reason? It's definitely something to ponder. Thanks for joining us on this deep dive.
It's been a pleasure.